Hi, I'm Herbert Gross, and welcome to lecture number 23 in Gateways to Algebra, where today we start the first in a two-part series on word problems. Now, it's very interesting that very often students will say things like, I could do everything in math except the word problems. And the unfortunate, or the fortunate thing is that in the textbook of life, the only problems that you ever have to deal with are word problems. See, no one's going to come up to you and say, how much is 9 times 3? But they might come up to you and say, at $3 each, how much will 9 ballpoint pens cost? So can you imagine if I say to a kid, how much is 3 times 9? And he says 27. Then I say to him, at $3 each, how much will 9 ballpoint pens cost? And he says, I don't do word problems. See, does that really say anything about understanding whether 3 times 9 is 27 or not? You see, the whole point of learning the algebra is to learn how to help quantify and solve certain real-life situations. Now, obviously, in a course at this level, we're not going to solve earth-shattering problems, but let's at least look to see how algebra is used in solving word problems. And again, let me just emphasize again how important that is. See, if there are 50 problems on a test, and only 5 of them are word problems, and you get 45 right, but you get the 5 word problems wrong, you understand what I'm trying to tell you? You may have scored 90% on that exam, but the 10% that you missed was the part that goes into what we call critical thinking in the real world. So let's just, without further ado, look at a few examples. I'm just making these up off the top of my head. It doesn't mean that much. John and Bill together have 30 marbles. John has 20 more than Bill. How many marbles does each have? Now, what we're going to do in this lecture is just talk about guessing. The next lecture will show how to use algebra. But the first thing I want to show you is, if you don't know how to do word problems, don't blame it on algebra. Let me show you how by simple arithmetic you should be able to get the answers just by trial and error and a little bit of experimentation. Well, by the way, sometimes people do what we call number shuffling. They'll see a 20, they'll see a 30, they say, gee, I have to use the 20 and the 30 somehow over here. So they say, okay, 30 take away 20 is 10, all right. John has 20 marbles and Bill has 10. By the way, if John had 20 marbles and Bill had 10, would they have 30 marbles altogether? Certainly, 20 plus 10 is 30. But that's only one of the two conditions. What's the other condition? It says John has 20 more than Bill. Well, if John has 20 and Bill has 10, then the difference between them is only 10. What's the difference supposed to be? 20. You see again, there are two dimensions here. What are the dimensions in this problem? John and Bill. Since there are two dimensions, there are two pieces of information that we're going to have to know. Now, both of these two conditions have to be obeyed. What are the two conditions? Let's take a look. The two conditions are the total number of marbles is 30. That's not going to change in this problem. The second condition is that no matter what else happens, John has 20 more marbles than Bill. What I'm going to do is look at these clues one by one and show you how by trial and error you can solve these problems. Let's use clue number 1 first. Remember, the total is that they have 30. And rather than to keep writing, this is the number of marbles John has, and this is the number of marbles Bill has, even though we're not going to use algebra here, let's at least use algebraic notation. Instead of writing how many marbles Bill has, why don't we just let B stand for the number of marbles that Bill has, see B for Bill, and let J stand for the number of marbles John has. What does it mean to say that together they have 30 marbles? It means if you add the amount that Bill has to the amount that John has, that has to come out to be 30. So in our abbreviated form, we're saying what? B plus J is 30. The number Bill has plus the number John has is 30. So let's make a little chart. B stands for the number Bill has. Now, what's the least number of marbles Bill can have? Well, he might not have any. He could have 1, he could have 2, he could have 3, 4, 5, 6. What's the most he can have? He can't possibly have more than 30 because altogether, Bill and John together have 30. By the way, notice that no matter how many marbles Bill has, Bill's marbles plus John's marbles have to add up to 30. So do you see how I've started this chart? Now you see what I'm going to do is, how can I figure out how many John has? Well, if I know altogether they have to have 30, and I know how much Bill has, if I just subtract the number Bill has from the total, that will tell me how many John has. See, 1 from 30 is 29. See what's going to happen? If I add any entry in the B column to the corresponding entry in the J column, that has to come out to be 30. You get the idea? Here, I've done this thing a little bit more completely over here. Okay? So you see how this chart goes? If Bill has 2, John has 28. If Bill has 3, John has 27. If Bill has 4, John has 26. If Bill has 5, John has 25. If Bill has 6, John has 24. Why? Because B plus J, that's the clue we're using, that has to be 30 here. But what's the second piece of information? The difference. Now, what is the difference? Since John has more, the difference is what? The amount John has minus the amount Bill has, but the word is the difference. What must the difference be in this problem? 20. So why is this the wrong answer? Because the difference is 30. Here it's 28. Here it's 26. Here it's 24. Here it's 22. Ah, here it's 20. Now, what does our chart show us? When the difference is 20, Bill has 5 and John has 25. Let's double check. If Bill has 5 and John has 25, will the sum be 30? Yes. And if Bill has 5 and John has 25, does John have 20 more than Bill? So again, the answer is yes, isn't it? And once the answer is yes, we don't need any algebra here, do we? All I had to do was what? Have a little bit of critical thinking and use a little bit of trial and error. And what's really neat about mathematics is that even when there's only one right answer, there's never only one right way to do the problem. That's another beauty about thinking. Different people can arrive at the same conclusion using a different path. So let's see how that applies to this problem over here. See, instead of using the fact that the total was 30, let's use the clue that John has 20 more marbles than Bill. In other words, now what we're going to start with is that if I take John's amount and subtract Bill's amount, the answer is going to be 20. Now let's see how the chart looks in that case. I got 2 pieces of paper stuck together here. Let's get them unstuck. Okay, what's the thing that's going to stay 20? I have the Bill column, the John column, the difference column, and the total column. See, now what we're saying is what? We're going to use the fact that the difference always has to stay 20. Doesn't Bill still either have 0, 1, 2, 3, 4, 5, or 6? Sure. But the difference has to be 20. In other words, notice that if Bill has 0 and John has 20 more, all you have to do to get John's column is what? Add 20 on to whatever is in Bill's column. For example, down here, Bill has 3, so John's going to have 23. Won't that make the difference 20? But what's the one piece of information we haven't used yet? We know that the total is J plus B. The total has to be 30, so what do? We just go down this list until we come to 30. When we come to 30, we simply read what the entries are over here, and this tells us again what? That Bill has 5 and John has 25. Now, by the way, can you see one flaw with this? Can you see one thing that was not nice about that? We were lucky that Bill had 5. What if Bill had 5,237? I mean, do you really want to track through that many columns to get the answer? I mean, are you going to draw a chart that has 5,000 rows in it? It's not a very practical way of doing it. So let's just change the problem slightly. So it'll be the same kind of a problem, only now with bigger numbers. This time we say John and Bill together have 200 marbles. And John has 40 marbles more than Bill. And the question now is, how many does each have? By the way, one way of tackling this problem is called the lucky guess method. The lucky guess method says, gee, what if Bill had 80 and John had 120? Let's see if that works. How many marbles are they supposed to have altogether? J plus B is supposed to be 200. And what else is supposed to happen? The difference is supposed to be 40, isn't it? And by the way, if you paid attention to our lectures on simultaneous equations, even though I'm not going to do this till next time, do you already see a simultaneous system of equations here? See how to read this? See, instead of just saying J is the first number and B is the second number, this says what? The number of marbles John has plus the number of marbles Bill has is 200. And the number that John has minus the number that Bill has is 40. And by the way, I didn't mean to do this now, but as long as I have it here, why not review? How can you get rid of the b's in this equation? This would be the algebraic way, and we'll talk about that more next time. The positive b and the negative b drop out when you add. J plus j is 2j. 200 plus 40 is 240. And if 2j is 240, divide both sides by 2 and find out that j really has to be 120. That would be the algebra way of doing this. But I'm saying suppose you didn't know that. Would this be the right way to guess? Yeah, but what's wrong with the guessing method, the lucky guess method? Not everybody is that lucky, right? You could have guessed wrong. Well, the amazing thing is if you understand how to think, there's no such thing as a wrong guess. Every guess is a lucky guess. Some may be more lucky than others, but every one is a lucky guess. Let's take a look and see why. Let's suppose I guessed, instead of guessing 80 and 120, suppose I had guessed that Bill had 70, all right? If Bill had 70, since they have to have 200 altogether, that would mean that John would have to have 130, right? Because 200 minus 70 is 130, okay? Now, they have to have 200 altogether. Now, how many more marbles would John have than Bill this way? If I subtract the 70 from the 130, I get 60. Did I guess right? No, because the difference is supposed to be what? 40. So the difference is too big. Okay, so that means that Bill has to have more and John has to have less so I can make the difference smaller. Okay, I'm going to guess 90 now. All right, if Bill has 90, since they have 200 altogether, John must have 110. But if John has 110 and Bill has 90, now the difference is only 20. Well, it looks like I guessed wrong again, doesn't it? But look at my two guesses. One guess was too big. One guess was too small. What that tells me is the number of marbles that Bill has to be somewhere between 70 and 90, and I can do the trial and error some more. Of course, I can be even smarter than that. I notice that 40 is halfway between 20 and 60, and since this is a linear relationship, there's a good chance, therefore, that what? The number of marbles Bill has must be between 70 and 90, and I would then take what? 80 is my guess, but if Bill has 80, John would have to have 120, and sure enough, that happens to work. Now, if you weren't that into this, you could have said, hey, let me at least start the chart so I can see what's happening. I know that their total has to be 200 here. So here's the B column, here's the J column, and the total column has to be 200. So if Bill has 0, John has 200. If Bill has 1, John has 199. If Bill has 2, John has 198. If Bill has 3, John has 197. And meanwhile, I can look at the difference column, can't I? Here the difference is 200. Here the difference is 198. 198 minus 2 is 196. 197 minus 3 is 194. We say, oh, this is really coming down. Where do I want to get to? I want to get down to where the difference is going to be 40. Well, this is going to take an awful lot of rows. But let me show you how I can use critical thinking here. Do you see the linearity here? Do you see that every time B increases by 1, the difference is decreasing by 2? You see why? Because every time Bill has 1 more, John has 1 less. And that makes the difference increase by 2 each time. Where do I want to get down to? 40. So I want a reduction of from 200 down to 40. That means 40 from 200 being 160 means I want to drop by 160, don't I? But every time I go from one row to the next, I'm dropping by 2. So if I divide the 160 by 2, that gives me the 80. And what does that tell me? It tells me I have to go down 80 rows. Well, the 80th row after the 0 row is 80. And if this is 80 and the total has to be 200, this must be 120. Now, by the way, there are lots of ways to do this stuff. I'm not going to dictate to you how these problems have to be done. I'll try to do them by different methods for you, but next time will be the real fun when we do them by algebra. Let me give you another John and Bill marble problem. This time I say John and Bill together have 500 marbles. John has 50 more than Bill. How many marbles does Bill have? Well, let me show you a different way. You could make the chart again, but this way, let me show you another way of doing this. Suppose they started out with the same amount. Wouldn't they both have 250? Now, how can you make a difference of 50 if the total has to stay 250? You can take what? 25 away from one, that will give him 25 less. Give those 25 to the other, that will still keep the total at 500. But if I take 25 away from one guy, give those 25 to the other guy, doesn't that make a difference of 50? Let's just check it out and see what happens. If I subtract 25 from 250, I get 225. If I add 25 to 250, I get 275. I claim that Bill must have 225 marbles and John must have 275. Let's check it. The 225 plus the 275 adds up to 500, which checks with this result. And 275 minus 225 is 50, which checks with the result that John has 50 more than Bill. So I've solved that problem. No matter how you word the John and Bill problems, I can still use my trial and error method. Let's do another one with these. By the way, there are more problems in life than John and Bill marble problems. But I would rather take one application and show you all the different ways that problems can come up. And you may say, well, there's more important things in life than John and Bill marble problems. Sure. There's more important things than crawling as an infant, but you can't walk before you crawl and you can't run before you walk. So we'll just start with these problems off gradually. And if we could do everything in Algebra 1, we wouldn't need Algebra 2 and Algebra 3 and all of those different subjects. Let's just keep on going then. Here's another example. John has 3 times as many marbles as Bill. They have a total of 120 marbles. How many marbles does John have? Just take any guess you want. I'll start with Bill's amount. Why? Because John has 3 times as much. I'd rather multiply by 3 than divide by 3, but I do have to have reading comprehension. In this problem, they asked me how many marbles does John have, not how many marbles does Bill have. But if Bill had 20, John would have 60, wouldn't he? Why? Because John has to have 3 times as many. But if Bill had 20 and John had 60, that would only be 80 altogether. How many are there supposed to be? 120. So this answer is too few. What if Bill had 40? 3 times that amount would be 120. So if Bill had 40, John would have to have 120. But if Bill had 40 and John had 120, altogether they would have 160, not 120. So now this guess is too big. What does that tell me? That John has to have more than 60 marbles, but less than 120. By the way, notice, again, just by coincidence, that 120 is that right? 120 is halfway between 80 and 160. Therefore, the guess I want should be halfway between 60 and 120. And I guess that would be 90, wouldn't it? The average of 60 and 120. 60 plus 120 is 180. 180 divided by 2 is 90. 90 is halfway between 60 and 120. Let's just try this. Halfway between 20 and 40 is 30. Okay? Suppose Bill had 30 and John had 90. Does John have 3 times as much as Bill? Yes. Is the total equal to 120? Yes. So we've solved that problem. It doesn't have to be John and Bill marble problems. Let's do another one. Let's see what I can find over here. Here's one. Mary has 30 coins, consisting solely of dimes and quarters. She has twice as many quarters as dimes. How much money does she have? Well, all you've got to do is say, okay, let's list the possible number of dimes. She could have none, she could have 1, she could have 2, she could have 3, etc. Okay? But she has to have 30 coins altogether. So whatever she doesn't have in dimes, she must make up for in quarters. So, okay? So let's see. She has 30 coins altogether, consisting solely of nickels and dimes, and she has twice as many quarters as dimes. Well, if she has no dimes, twice 0 is still 0, so she'd also have no quarters. If she has 1 dime, twice 1 is 2, so she'd have 2 quarters. If she had 2 dimes, she'd have to have 4 quarters, 3 dimes, 6 quarters, etc. But what's the important thing? She has to have 30 coins altogether. Well, look what happens over here. There's none, 3, 6, 9. Aren't these going up by 3 every time? So how do you get to 30 starting at 0, counting by 3s? You have to get from 0 to 30, that's a change of 30. Each time you jump a row, you're gaining 3 coins. 3 goes into 30 10 times. That tells you want to be where? In the 10th row. If you're in the 10th row, that gives you 10 dimes. How many quarters would you have? 20. Does that check out? 20 is twice as big as 10, and 10 plus 20 is 30. Again, you have to be careful. It doesn't say how many of each coin does she have. It says what? How much money does she have? So even though the chart doesn't tell you that, what does critical thinking now tell you to do? You have to multiply the number of dimes by 10 and the number of quarters by 25, and you wind up with what? 10 dimes is $1, 20 quarters is $5, so altogether she has $6, okay? And we could have, we could do this a different way too. You could have guessed higher. You could have said, hey, what if she has 4 dimes, then she'd have to have 8 quarters. That would only come out to 12. So we know what? She needs more coins. You don't have to start at 0. See, we do want to wind up with what? 30 coins. Where are we right now? It's 12. How far do you have to go to get from 12 to 30? 12 from 30 is 18. But each time you move down 1 row, that's changing the number of coins by 3. Therefore, since 3 goes into 18 6 times, how many more rows do we have to go down? 6. But if you're adding on 1 each time, by the time you get down 6 more rows, isn't this going to be a 10 over here? See, 4 plus 6 is 10. Okay? And so this is going to be what? 10 and 20. You get the answer this way too. Again, you see, more than one way to solve the problem. Let's just, could you have 3 variables in the problem? Let's just take a look and see. Here's one. We have time for one more, I think. John has 3 times as many marbles as Bill. That starts to sound the same as before, except now there's a 3rd guy in here. And Tom has 4 more marbles than John. Starting to sound like a tongue twister again. Together, they have 214 marbles. How many marbles does Tom have? Well, again, could we start a column with Bill, John, and Tom separately? What would happen? What do we know for sure? Let's suppose that Bill could have 0, 1, 2, etc., okay? Now, how many does John has? John has 3 times as many as Bill. So if Bill has none, 3 times that amount is still 3. It's still 0. If he has 1, 1 times 3 is 3. If he has 2, 2 times 3 is 6. You see how this chart is going? Now, what's the T stands for the number of marbles Tom has. What are we told? Tom has 4 more marbles than John. So if John has 0, Tom has 4. If John has 3, Tom has 7. If John has 6, Tom has 10. And by the way, do you see what's happening? We want to get to where 214 is the total. We're all the way down at 4 over here. But do you notice something interesting happen? As you go from row to row, from 4 to 11, there's an increase of 7. From 11 to 18, there's an increase of 7. We're increasing by 7 each time. See, let's take a look here and see what we can do. We're at 4. We want to get to 214. So the difference, 4 from 214, is 210. Every time we go down 1 row. And by the way, do you see why the slope here is 7? Why the change is 7? See, every time Bill's amount increases by 1, what happens to John's amount? That increases by 3 because it's 3 times as much. And what does Tom always have? 4 more than John. So if John has 3, 4 more would be 7. 3 plus 4 is 7. That's where your 7 comes from here. But you don't have to know that. All you have to observe is that this keeps changing by 7 each time. So in other words, we have to go through a change of 210, 7 at a time. How many times does 7 go into 210? 30. So what that means is we have to go down 30 rows. Won't that make this 30? Once I know this is 30, what goes into John's column? John has 3 times as much as Bill. So if Bill has 30, John must have 90. And Tom has 4 more than John. So if John has 90, Tom must have 94. And it looks like Bill has 30, John has 90, and Tom has 94. Let's check it out. What's the one piece of information that has to check here? That if I add up all these 3 amounts, it comes out to 214. Oh, I hope this works. Otherwise, we've got to do the whole lecture over again. Let's see. Let's hope. 4, 9 and 9 is 18. 18 and 3 is 21. Yep, it works. By the way, again, you need reading comprehension. The problem might say, how many marbles does Bill have? In which case, the answer would be 30. If the problem said, how many marbles does John have? The answer would be 90. If the problem said, how many marbles does Tom have? The answer would be 94. Okay? So even when you solve a problem, you have to see which variable you're looking for. But the thing I wanted you to see that I think is so important is I will hear students say time and time again, I wish I knew algebra because I can't solve word problems without it. The thing I want you to understand that the one thing in the world that you don't need algebra for is for solving the average word problem. All you have to do to solve a word problem is to understand what the problem is asking you for and then take a guess. If the guess is too small, you try something bigger. If it's too big, you try something smaller. And eventually, you'll zero in on the right answer. However, in certain problems, we first of all want an exact answer. Secondly, we want it quickly. And thirdly, we want it systematically. And trial and error, even though it always works, can sometimes be very, very tedious. So what we're going to do in the next lecture is revisit many of these same problems, only using algebra. And if you noticed, we solved one of these problems by algebra earlier, and you saw how quickly the answer came out. But anyway, let's stop now at this point, and before we pick up next time, look this over, study hard, have fun, stay young. Talk to you next time. Bye-bye.